Hello and welcome to episode 1.2. Today we'll be talking about logical arguments. So there are two main parts of a logical argument. So the first one, well technically it's the last one, it's the last statement you make, but it is called the conclusion. And it's basically what you're trying to prove. So let's say you're trying to prove that the area of a rectangle is A is equal to length times width, or other way around, same thing. So you would have a bunch of different statements that build up to try to prove this, and then your conclusion is that this is true. So that's what a conclusion is. It's just what you're trying to prove. The premise is what you say before the conclusion to try to build up a foundation of knowledge for the conclusion. So, for example, let's say we're trying to prove that A is equal to LW. The premises would be all of these statements that you make up here. So you can say that the length of a rectangle is a real number, the same thing with the width, and then you can build on top of that. So the premises can either be false or true, and this is getting a bit ahead of this, but if you say that 2 is less or is greater than 3, you can still properly use that in a logical argument. So in this case you would have two premises, because these are the two things you're saying that prove this statement. So P for premises, and this is the conclusion. So the premises, premises, I don't know the plural, but basically you start with a foundation of facts, which is the premises, and then you build up to your final conclusion, which is this. So there's a thing called common form, which is basically trying to take this down into a into kind of like a generalized example. So basically what you do is you replace the statements, so like this statement and this statement, this statement and this statement. You're basically trying to replace all of the case specific words with variables. So we can say that this is equal to P Q, and then because these two are the same statements, you say that this is P, and then since these two are the same statements, you say that this is Q. So all you do is you just replace these statements with these variables. So if P then Q, my mouse keeps jumping around. If P then Q, and then you basically, all you say in this case is just P, because that's just saying Bob is 32. And you say therefore, and there's a symbol for therefore, it's just 3 dots in a triangle, like that. So therefore, Q. So that's basically what you do. You just take it into a generalized example. And what I mean by that is it's not in a kind of specific form. Like in this case, this argument right here is specific to Bob. But if you wanted to create a generalized example, you would say this argument. So let's do another example. This one's a bit more complicated. So the first thing I do is I just break down the statements. So if, and then the car has a spoiler, and or, that's going to stay the way it is. Then you can say that this is your next statement, then will stay the same, so then you can say this. And then you have the car is not expensive, which is the same thing as this one, so that's going to be the same variable. Therefore, that stays the same. The car does not have a spoiler, so that's going to be its own statement. But it'll still use the same variable, but I'll show you how to do that. And then you have this statement right here, repeated, except this does not have a spoiler or leather seats. So that's what you do first. And then you just assign these variables, so we'll call this P, Q, that's hold on, let me erase that. So we have P, Q, I skipped one. Okay, we'll call that Q, and then we'll call this R. So now we just break this down. So if P, because you see we're just replacing this whole statement with P, or, and that says the same, or R, then Q. And then because these two are the same, this one is also Q, so you just say Q. You don't have to say anything else. You say therefore, which again is just 3 dots and kind of like a triangle like that. Therefore, and then we go back to the red, which is P. Or okay, actually no, I just forgot. So because it says, okay, so look how this says the car does have a spoiler. The does is implied, but this says does not. So all you do is you say not, and then the variable. So not P. And then same thing here. This is the car does have leather seats, but this is does not. I just realized you can't see my pointer, but here's a pointer. You say that the car is expensive, or sorry, the car has leather seats. So the car does, but the car does not have leather seats down here. So again, what you do is you just say not, and then the variable, which in this case is R. So that's basically how you do this. So now let's work backwards. So there's infinite amount of answers to this because you can put any single thing you want to for X, Y, and Q. So let's just say that X is equal to, say, Bill is 32. And we can say that Y is, let's just say Bill is I'm trying to think of an example here. Let's just say that Bill likes pizza. And I'll draw a triangle for pizza because I don't feel like writing that. So yeah, Bill likes pizza, and then you say Q, and then this is just going to be whatever. Okay, so Q is going to be your conclusion. So keep in mind conclusion, premises. So Q is going to be whatever you're trying to prove, and let's just say we're trying to prove that, I don't know, Bill is watching TV. And again, this makes no sense in terms of like actual storytelling, but you can put anything for these and it would work as long as you follow the rules. So there you go. So let's just plug these back in. So if Bill is 32 and Bill likes pizza, then Bill is watching TV. And we state that Bill is 32 from right here, and we state that Bill likes pizza right here. Therefore, because if you know that if these two things are true right here, then you know that Q is true. You can imply from this right here that Q is true. So therefore, Bill is watching TV. So as a bit of a recap, a logical argument consists of premises and conclusion. So conclusion is what you're trying to prove, and premises are basically like facts or kind of previously proven things that help build up a logical foundation to get to your conclusion. Common form is basically just replacing kind of more specific details with variables. So like if P or Q, then R, and then you can go on down to here, and then therefore, again that's just 3 dots in a circle or in a triangle, R. And in this case, these would be your premises, and this would be your conclusion. So that's all common form is. It's basically just removing the specificity out of the logical argument.